Homeschool chemist, and today we're going to look at an example problem where we have to determine the limiting reactant before we can perform the chemical calculation. Also, in this example problem, we will have to know our polyatomic ions. So, the question reads, we are given nitric acid and calcium carbonate. We have 14.23 grams of nitric acid, and we're reacting it with 22.98 grams of calcium carbonate. And we're asked how many grams of excess reactant will remain. Now, we don't know which reactant is going to be in excess at this point. So the first thing we need to do is to write a balanced chemical equation. So we're given all the species in this problem. We are given nitric acid reacted with calcium carbonate to form carbon dioxide, water, and calcium nitrate. So if we were going to write a balanced chemical reaction, it would be HNO3 plus CaCO3 will form CO2 plus H2O plus CaNO3 2. Now, since calcium forms a 2 plus cation, and if you remember from learning about polyatomic ions, nitrate is a 1 minus anion, so we need two of them to balance the charge for the calcium. So if we're going to balance this chemical equation, I'm not going to show you how to do it in this video. I have other videos where I show the algebraic method for balancing chemical reactions, but for this chemical reaction, the balancing is going to be 2, 1, 1, 1, and 1. So it's not particularly difficult. Okay, so the next step, we need to find the limiting reactant. So in order to do that, we're going to take the 14.23 grams of HNO3, and we're going to find out how many moles we had. So we were given the molar mass, so we don't have to add it up. That's nice. So 1 mole of HNO3 is equal to 63.01 grams. Now when we take 14.23 and divide it by 63.01, we're going to find that we have 0.226 moles of HNO3. Now, to find the moles of calcium carbonate, we take the 22.98 grams of CaCO3, and we are given the molar mass again, and it is 100.09 grams per 1 mole. So 22.98 divided by 100.09 is going to be 0.229. Okay, so it's pretty easy to see which one is going to be limiting in this case. We see from our balancing coefficient in our balanced chemical equation that we're going to need 2 HNO3s for every 1 CaCO3. So if we take, to find which one is going to be limiting, if we take the moles of nitric acid and divide it by the moles of calcium carbonate, if this number is going to be less than 2, then we know that the nitric acid is going to be limiting. So 0.226 divided by 0.229, and what we find is this is equal to 0.98. What this is saying is we have 0.98 moles for every 1 mole of CaCO3. If HNO3 would have been in excess, this number here would have been greater than 2. But since it's less than 2, we know that HNO3 is limiting. So now that we found out which one is limiting, now we can solve the rest of the problem. So we would say that we have 14.23 grams of HNO3, and 1 mole is equal to 63.01 grams. And we know that we need 2 HNO3s for every 1 calcium carbonate. And that calcium carbonate is equal to 100.09 grams. If we multiply this through, we find that we are going to use 11.3 grams of CaCO3. Now, this is how many grams of CaCO3 we used. To find what remains, we need to take what we had to begin with, which is 22.98 grams, minus 11.3 grams, and we find that is equal to 11.68 grams of CaCO3 remain. And that is our final answer for this problem. I'd like to point out, when we're doing these problems using dimensional analysis, we see that grams of HNO3 cancel out, and we're left with moles of HNO3. Now moles of HNO3 cancel out, and we're left with moles of calcium carbonate. The moles of calcium carbonate cancel out, and we are left with grams of calcium carbonate. And that is how we solve this problem.